Hello everyone, welcome back to my YouTube channel, and this is the last video of our tutorial series. And at the beginning I have told you that our digital circuit for logic gates includes mainly two types. They are combinational logic gates and sequential logic gate. When we consider about the combinational logic gate, the output will be as a result of the present input. And when we consider about the sequential logic gate, in contrast to combinational logic gate, here the output will be the sequence of inputs plus internal states. Okay, so that is the main difference also between those two. Here in the sequential logic gate, in addition to logic gate, there will be a memory element. Memory element will be presented here. That is the main difference. And when you see the block diagram of this, also you can understand that clearly. Here the inputs and outputs are there, and also here in addition to the circuits, memory element is also there. So the function of the memory element is to save the past output. So past outputs will be saved there and it will be used for the next input. Okay. So some examples of sequential circuits are latch, flip-flop, counters, frequential dividers, and registers. Now let's move to our next slide. And here I'm going to design an SR latch by using logism software. Before that, I would like to tell you SR latch can be designed using two gates. They are NOR and NAND. Here, by using the NOR gate only, I'm going to design my practical part. And also I would like to tell you that the bicycle element is able to remember or store one bit of information. So it will store or it will remember the last one bit of the information. And also if the set inputs goes high for even a moment, the output goes high and it stays high even after the set input returns to low. Once we set the set input as here, there are two inputs, namely S and R. The say S is for set and R is for reset. Okay, and the outputs are Q and Q bar. So once if we on this S as high, once if we put this S as high, then even if we off that also, even if we give 0 for that also, that Q will be 1. That means the output will be high. Okay, and once when we reset the input, that means when we make this R as 1 only, it will go low. Until that it will remain as high. That is the main thing that we have to know about this SR latch. Okay, now let's design this SR latch by using logism software, and let's analyze this whether the result are correct according to the available in the presentation. Now for the easy reference, I'll take the presentation also with me and I'll design this. So to design this, what we need is only two NOR gates. So I'll take the two NOR gates here and I'll change the number of inputs as 2. Here also I'll change the number of inputs as 2. Now it's done. So I want to take two inputs R and S. So set and reset, and two outputs Q and Q bar. Even we can join an LED instead of this output terminal, because then it will be easy for us to see whether the light is on or off. That will be easy for us. Here this one, in one terminal the input will go directly, the other terminal the output of that one will be as the input of the other. So that is the only thing that we have to remember here. So it is very easy, we can check it very easily. Okay, now you can see the red part, that is the output is coming as an input of the other. Okay, now let's check whether the results is coming like that. Okay, when this is 0 0, then that is default as a latch. Okay, now let's change this R as, okay, before that I want to name that. I forgot to name this I will label this as R. Okay. Here you can see when I change this R as 1. According to the second situation, when I change this R as 1 and S as 0, then we can see that Q bar is on. So this is the Q bar now. So that is on here. And also now I will make this as 1. So I will name it as S, that is set. So S as 1 and R as 0. I'll make this R as 0. Here you can see that Q is 1. So Q is 1. That is also correct. Third incidence also correct. So I will name this as Q and this as Q prime. Q prime. That will be Q prime. Okay. Q bar or Q prime. So I have named it as like that. So here you can see that when I put 0 for R and 1 for S, here you can see that this Q is on here. Q is on here and Q prime is off here. So that is also correct. So I have already told you, once the S goes high and if we press that S as 0 also, that will remain 1. So there is no change in the circuit. So even if we press it again and if we change it as 0 also, it is remaining as 1. So this is the amazing thing available here. That is because the memory is saving that 1 bit of information. Because of that only we are getting the same output again. Okay. So if we want to change this again, then we want to make this R as 1. We want to bring this R as high. If we bring that only, that will change. So now you can see Q prime is 1. So this is the very amazing thing available in this SR ledge. And also when we make this both as on, definitely Q and Q bar will be low. So Q and Q prime will be low. So I think it is clear for you. So let's save this and let's move to our next slide. So I will save this. I'll save this. Okay. Now I'll close this and let's come back to our presentation. So that is about SR ledge and it is working very clearly. So we have seen that nicely by using our logism simulating tool. And now let's talk about counters. There are two types of counters available. They are synchronous counters and asynchronous counters. So it is a theory part. I think it is a must for us to know that there are mainly two types of counters, synchronous counters and asynchronous counters. And when we talk about BCD or decade counters, a decade counter is a binary counter that is designed to count to 1010. That means 1010 means we know that is 10 or 10102. Okay. So it is used to count these types of things. So I didn't do this because by using the logism software, we can't show the time diagram. So time diagram is not possible in the logism simulating tool. So if we want to see the timing diagram, then we have to install see the logic circuit or any other simulating tool where this timing diagram is available. So I didn't do this here. And also I'll move to the next part, that is frequency divider. Frequency divider can be constructed from a JK flip-flop by taking the output of one cell to the clock input of the next. So here, as I have already told you, sequential logic circuit means the presence of memory will be there. So here it will save the past output of it and it will take as the clock input of the next. So for this also we have to see the timing diagram. So it is not possible in the logism simulator tool. So I didn't design that using the logism simulator tool. And finally, we can have a look on registers. So register is an example for sequential logic circuit. To increase the storage capacity, we have to use group of flip-flop. This group of flip-flop is known as registers. Okay. So to increase the capacity, the usage of flip-flop, a group of flip-flop is needed. That group is called register. And also register can be classified mainly into two types. Basically depending on the input and output and depending on the application. Okay. So here, depending on the input, we can name it as SISO, SIPO, PISO, PIPO. Here, this is sequential and this is parallel. And also depending on the application, we can depending on the application, we can see that shift register and memory register. So that's all about the registers. And thank you so much for watching my tutorials patiently. All these 9 tutorials are really a helpful tutorial if you are one of the students who is doing any IT relevant degree with an electronic subject as one of your module. So in the electronic subject, you will definitely learn microcomputer architecture and logic gate designing. So in that chapter, the necessary of knowing about these things and using the simulating tools to design our programs are really important, because in future definitely we will be a programmer, or we will be assigned to do a task for a particular device. In that case, it is needed for us to check whether what we have already done is perfectly okay before implementing that on the main device. So when we have these like simulating tools, then that will be a very great help for us, where we can check each and everything before implementing it. And once if we get the desired output for the inputs that we give, then definitely we can implement that on the main device. So I want to thank my professor for giving us an opportunity to do these kind of tutorials and publish that on our YouTube channel. So with that note, I would like to wind up all my tutorial series relevant to this. Let's meet in any other topics. Till then, goodbye.